All of us in the Koch Institute are biologists and engineers working together to tackle cancer. And there's a subset of us that are really interested in exploiting this set of technologies that have come out of other worlds, which include micro and nanotechnology. Some of them came out of the physics community, and some of them came out of the microfabrication community. And we're all collected in the Marble Center for Nanomedicine.
We helped create some of the first nanoparticles and microparticles that could deliver large molecules. I mean, that goes back over 50 years. But that would ultimately lead to things we're doing today, like figuring out how to deliver genetic medicines to patients.
We evolve organisms to grow materials. Anything we're interested in, we can have them learn and genetically program to grow those materials. And we're only interested in materials on the nanoscale, really, because materials at the nanoscale have such fascinating properties.
A nanoparticle might be a system that allows us to see through a range of different optical methods where the cancer is, while at the same time allowing us to administer a drug.
When you're reprogramming cells for uses as treatments, these have been done up till now largely by taking the cells out of the body, manipulating them in a dish, growing them up. So that's great. It's enabled life-saving treatments, but it's also something that's incredibly expensive.
We think it may be possible to do that without taking cells out of a patient and changing them. Maybe we can build nanoparticles that go in and do the repair in a patient. And we're optimistic that for many diseases, it may be possible to give one infusion that could be a therapy for the lifetime of the patient.
And this actually started, the federal government started this 20 years ago. There were several centers around the country that were funded by NIH. They were called the Cancer Nanotechnology Excellence Centers. And we had one joint between MIT and Mass General. But we felt like the work was not done. Actually, it was a really exciting time in the biology of cancer where we were realizing that we could talk to the immune system and then we might be able to use sequencing technologies to find cancer really early. There's a whole new wave of opportunities. And so that was why we formed the center.
It's a place where bold ideas turn into transformative advances that help cancer patients and non-cancer patients as well.
All of the things that are happening in biomedicine are overlaid on this accelerating moment, and now we have AI. And for the trainees in the audience, like, you're here at just the right moment. So welcome to our anniversary, our birthday, our celebration of the Marble Center. We're so excited to really be here with you and have a chance to reflect on our journey and our goals for the future.
Of course, this could have been done without the incredible support from Kurt Marble, who's with us this evening. Kurt, thank you for believing in our vision, and thank you for your generosity and your support.
Kurt is a businessman, and so when he started the center, he started it with very concrete milestones over 4 years, and if at the end it's going well, we'll continue supporting it. We're happily on the other side of that. We wanted to sort of have a chance to reflect on how far we've come and really celebrate that progress. And we thought we'd do it through the lens of Bob, of course, who's been here from the whole field's beginning. And then specifically from some of the trainees that have come through the center, who invented things, who started companies, and are taking their inventions to the clinic.
That can reach patients.
Kurt has made such a difference to so many people. All of us in the Marble Center feel very privileged by what he's enabled us to do.
Without his passion and his desire to make a difference and his very deep understanding of the science and engineering, the kind of work that we are doing wouldn't be possible.
This is a time to look back, reflect, and see what wonderful things have come out of the center.
Technologies that are now in the clinic and have real potential to help people. And importantly, it's also allowed us to train the next generation of scientists.
What has happened in the last 10 years, we will look back 10 years from now and be like, that was just the start.
There's an idea out there called cancer interception. It's like you throw a football and it's headed to a bad place and you want to catch it before it makes it there. And in that vein, Cancer is born in all of our bodies at some point in time, and your immune system can clear those cells. So we're really trying to understand what are those earliest stages of what would be a lethal cancer, where we could find it and treat it. That's really a future that we want to be a part of and we want to lead.